In the last video, we saw scope of a variable, particularly if a variable is defined inside a function, is it accessible outside the function? And if a variable is defined outside the function, is it accessible inside the function, and vice versa, and so on. So we discussed those kind of things, which is sometimes called scope of a variable. And further, we discussed what if we want a value of the function that is computed, value of some variable or some result that is computed inside a function. What if we want that to be accessed outside the function? So we discussed that in detail in the last video. So let's see all those concepts in a running form in Jupyter Notebook. So let's see how it works. So first of all, let's define a variable. Let's define a function. Let's say define let's say my add, and let's say it receives two arguments, let's say a and b, and then let's say c is a plus b. Let's say that's c, or c value, let's say c value or some value, whatever you want to call that value, some value. That's it. Let's say we did that. Now we want to access that some value from outside the function. Print some value. By the way, let's first call this function. Let's say my add for values, let's say 2, 3. So 2 will be copied in A, 3 will be copied in B. So then let's try to access this value, some value. It will throw an error, and the reason is this variable some value is not accessible outside this function. What if we want to access, because this is defined inside the function, what if we want to access this, what if we want to compute some result and then use that result outside the function? So the way out, as discussed in the last video, is return statement, return value. And now if we call that again, if we call that again, now we haven't actually registered. By the way, remember this, that's a common error. I got in that error a lot many times. If you change the implementation of the function, you have to rerun that cell. You have to register the updated copy of the function to the Python. Otherwise, you will be getting errors. Probably, yeah. What's the problem here now? Print some value. This some value is still not accessible, because some value is not accessible. It is a variable defined inside the function. It is the scope of this variable is just the body of the function. So let's receive this output in a variable d, and then let's just print d, and d is 5. Great. So one more thing, let's say we define a variable here, a variable outside the function. Let's say that's a variable name. That's a very lengthy name, but let's say that's a name. Variable outside the function. Let's say its value is 3. And then let's define another function somewhere. Let's define another function down somewhere. Let's say define f maybe g, and it receives nothing, but it prints this, let's say variable outside the function, and that's it. Let's say that's a function. Now when we call this function, this variable outside the function, that is accessible inside the function. And if this function, and if this variable, it is not defined inside here, and if this is defined somewhere else and it is global or accessible, it will still be accessible. However, if we define a function with the same name let's say variable outside the function, let's say 5. Now this function will print 5 if we, because that's the local variable, that's a local variable in the function. Now this will be accessed in this print statement. Let's see. Now the result will be 5, but if you print the variable outside, now the value will be 3, because this variable, this particular variable that was inside the function, it got destroyed when the function finishes, and this is available again. So yeah, so you need to know, by the way, it's a good practice whenever you want to access particular variable inside, it is a good practice to pass that variable as input argument to minimize the confusions, because this can create a lot of confusions. So it's a good practice, although the feature is available and sometimes useful as well, but it is always recommended to pass the values as input arguments, that whatever you want to access inside the function. Okay, so one more thing, this function g is returning nothing. For example, it is not returning anything, it is just printing, let's say, something. Let's say it is not printing anything. Let's say this is a comment. Let's say it is not printing anything. So this, and then we call this, and that's it. So it has no return value. By the way, in Python, even if a function does not return anything, it still returns a value which is called none, which you can see here. So in Python, a function always returns a value. If you write a return statement explicitly, it returns that. If you do not write return statement, when the function body finishes, it automatically returns none. Let's see the type of this output. What is the type of this output? What is the type of this none? What kind of data type is this? Let's see. It's a none type. I mean, that's a type in Python. So it returns a none type output. How fancy. Wow. One more thing, the return statement is not only used to return a particular value. If you, for example, in a particular function, let me write a function here, let's say def, let's say the function is h, and then inside that function you do something, let's say print a, let's say then you define a variable, let's say a equals 2, 3, let's say, then b equals, let's say 5, and then you add those values a and b, and then you do some other stuff, let's say print something, and then you just write a return statement without any output argument. I mean, it is not returning anything. You can still I mean, continue writing the function body more and more, but what happens is, whenever the first return will be encountered, the function returns from there. So the effective body of the function is just that. The function returns right from there. If you return a particular value, for example C, you can receive that value outside the function. If you do not return anything, just type a return statement. That means exit the function right away. It works like the break statement in loop. Remember the break statement? It resembles to the break statement. Return means just exit the function right away, no problem. And by the way, when return is called, the default return value that is returned is none type if the return is called without an argument here. So for example, let's run this function. Let's see, and let's call that function h. Yeah. So it prints a, then it prints something, and then it returns. And it returns, for example, it returns nothing but a none. It returns a none. And if it returns C, for example, C, then it returns a C, value of C, which is 8. And this time, the return value is no longer none type. It is probably an integer type. Let's see. Yeah, here. So it's integer type. Make sense? Yeah. So return statement has two purposes. One, you can return a value. Two, you can return you can just return the control. You can just exit the function like the break and loops. Just one more thing. A return statement can return multiple values. For example, let's say we have defined a function. Let's say j. Let's say g we already have defined. We can redefine it, but let's say r is our function, and we just have a equals 5, b equals 7, and d equals, let's say, something, and then we just return them a, b, and d. So return statement can return multiple values in a sequence. Now if you receive those values, let's say x, y, and z equals r, so a will be copied in, a is the first return value, it will be returned in x, it will be copied in x, b will be copied in y, and d will be copied in z, just as a sequence as you keep the sequence in the return statement. If you change the sequence in the return statement accordingly, so whatever the first value here is the first value here, whatever the second value here is the second value here, and so on. So let's run this and just print all these things, x, y, and z. So yeah, 5, 7, and something. So this return statement is really powerful. I mean, it can return multiple. Not all the languages actually, they have feature to return multiple values, but Python does have feature to return more than one values, and more than one values of any type. A can have different type, B can have different type, D can have different type, and so on. So that's about the return statement, as well as the variable scope, and whether you can access a variable that is outside the function or inside the function, and so on, and all that kind of things. In the next video, we'll talk about what if we want to access arbitrary number of input arguments. I mean, we do not know how many arguments will be there inside, but no matter how many arguments a particular user is giving, let's say we want to write an add function, just to give you an example. Let's say we want to write an add function. Let's say define add, let's say add2, another function add2, and let's say it receives an arbitrary number of arguments, d in, I don't know how many, and it has some implementation. Then anybody who want to call this add2, if that person gives two arguments, then just 2 should be added. If the person gives 3 arguments, then 3 should be added. I mean, the person can give arbitrary number of arguments. How can we handle that? Because the caller, this is the call, the caller can give 5 arguments, 6 arguments, 7 arguments, and earlier we saw in the definition the total number of variables. When we specify, we have to pass those many arguments for sure. If a single argument is missing, or a single argument is just more than the specified number of variables, we will be getting an error. But how can we handle this situation where we have an arbitrary or variable number of input arguments? How can we handle that? So to answer this, or to get how can we do that, see our next video. It's coming.